Okay, so last time we were talking about drainage basins and how drainage basins can have what we call sub-basins of a larger main drainage basin. For example, the Yellowstone River drainage basin is the whole river where it then all of a sudden connects to the Missouri River, because the Yellowstone River is a tributary, a river that goes into another larger river of the Missouri. And the Missouri River is a tributary of the upper Mississippi, which is a tributary to the lower Mississippi, right? And then it goes out into the ocean. So these are all distinct tributaries of it. For example, here's another one. Here's the Yellowstone River, but the Bighorn River, the Tongue River, and the Powder River here are all tributaries to that river, right? And they each have their own distinct drainage basin. So if water to drop right here, some of that water might go to the Tongue River, some of it might go to the Powder River. So there's a drainage divide in between these two to form a smaller drainage basin that goes into the Yellowstone River. You get it? I hope so. But it's this area where all that water will go into. Now, in that drainage system, we have the uplands here, or the upper portion of the drainage basin. Usually have smaller streams, and as you go down to what we call the trunk of the stream, it gets larger and larger. And that should make sense because you're adding more water to a channel, which means that if you have more water, you have to have a larger space to hold that water. And so the channel gets larger and larger as you go downstream until you get to near what we call the outlet or the lowlands of a stream. And those ones don't have as many tributaries as in the uplands. Then we'll talk more about these a little bit later as we go on. So here's some other major drainage basins of North America. Okay, so we have the Mississippi drainage basin, which is this area right through here. Okay, and then we have the Atlantic drainage basin in this region here, and then some of the Mexican ones, and the Great Basin and the Pacific Basin and so forth. Okay, so these are all specific basins that actually have water going to those larger streams or oceans in some way. Here are the North Carolina's river basins. So, for example, we live here the campus is here near Pembroke, right around here, and so we're in what we call the Lumber River drainage basin. And up in the highlands, where the river starts, is up here near, let's see here, that's up in Moore County area, right? Okay, and then it will flow down through Robinson County, then out into South Carolina, then it keeps going right here, and then we'll go out near, down here near Myrtle Beach area, right? So that's the Lumber River here. Whereas the PD, which is, sorry, not the PD, the PD, which would be one over, yeah, the one over here, this is the PD. Okay, it goes all the way up through near Charlotte, and actually Charlotte's over here more, but all the way up through the Wari regions of Gold Hill and these areas here, all the way up. And then it goes out through South Carolina as well, and it goes out to the south. Okay, so these are examples of some other drainage basins. So when I live actually near Fayetteville, and so I actually drive past a hydraulic divide every single day, going from the Cape Fear drainage basin into the Lumber River drainage basin. Okay, so any water that I actually water on my lawn actually ends up in the Cape Fear River, not in the Lumber River in its basin. Okay, so just like we were talking about before, there's some basic parts of a drainage basin. You have what we call the headwaters up at the top. We have lots of tributaries. Okay, and then you get to what we call this area here, which we call this trunk stream. Okay, and then we get to the bottom, which we call distributaries. Okay, a tributary is something that is given up to a larger thing. We already kind of talked about that. So the smaller streams go into the larger stream, and a distributary is when something gets distributed outwards. And so the larger entity is giving out to smaller entities. So so you have the big stream that goes into smaller streams. So here's a distributary channel that's often what we call in the areas that we have deltas, or the water all of a sudden slows down, and so therefore it distributes out over a large area. And then up here is where it's kind of speeding up in a sense. It goes all the way down to that central point to actually go to the trunk stream. So down here at the bottom where it slows down, we call this the zone of deposition. The water velocity is actually slowed down enough where sediment can actually drop out of the water because it can't push that water anymore. That's the sediment anymore. Whereas this area here is what we call the zone of transportation, where the sediment is being transported. And the headwaters is the zone of sediment accumulation or zone of sediment production, where it's being eroded. Right? So up here is where a lot of the sediment comes from, and then it goes all the way out to the mouth. So for example, the mouth of the Cape Fear is near Wilmington, and that water from the Cape Fear River comes all the way from up in Greensboro area, those areas here, and going all the way down, breaking down those rocks from all the way up there, all the way down into the Cape Fear, and that sand in the beaches there has been deposited from that river that's out off the coast there. Okay, so we have what we call the zone of sediment production, zone of transportation, and the zone of deposition. All important parts. Okay, so erosion, transport, deposition. If you remember when we talked about sedimentary rocks, the process of a sedimentary rock is it breaks down or gets eroded first, gets transported, then gets deposited, and this is how it happens within that river. Okay, so remember this. When we talk about streams, we're going to be relating back to a lot of the materials that we talked about when we talked about sedimentary rocks. Okay, because it's the same kind of processes that are occurring here. Because water is one of the main sources of the breakdown of rocks to form into sedimentary rocks. Okay, so as the stream goes down, it's going to change. And so it changes as it goes along its length. Up at the top, which we call this is what we call a longitudinal profile going from the top to the bottom, whereas a cross-sectional profile goes across this way. Now you'll notice that up here, okay, the slope is higher. Okay, what we call the hydraulic gradient is higher. So the per 1 foot forward, we go down like 2 feet or whatever. Whereas down here, per 1 foot forward, we only go down a couple of inches, right? So it becomes much more shallow down here. So it's slowly changing. So higher velocities, higher in-stream velocities there, a lot more erosion. In reality, the actual water speeds up a little bit as it goes down, and we'll talk about that a little bit later. But a lot more erosion, a lot more friction up here, a lot less down here. And so it slowly changes as it goes down, okay, from high elevation to low elevation. Notice up here, lots of tributaries. Through here, not really many tributaries at all, okay, and then lots of tributaries again. Also notice there's a place in here that has a little bit of distributaries here. Distributaries, tributaries. Okay, so when you talk about a stream, you first have to talk about erosion, right? So that's that zone of erosion up here, the headwaters. And there's basically, water can erode a bed in 3 different ways. It can do it through hydraulic action. You probably all have experienced this before. You've got maybe your hose here. You put your finger over the hose and actually limit the amount of space the water can come out so it goes out faster, right? Okay, and then you spray off the porch or spray off the sidewalk to get all the dirt off, right? So it's the actual force of the water that's actually moving the sediment. Okay, so that would be a type of stream erosion, which we call hydraulic action. The next type of stream erosion that we have is what we call abrasion. So once the rock actually starts to roll down the stream, okay, let's say I have this rock here and it starts to roll down the stream, it's actually going to hit the bottom of other rocks and stuff like that and start to actually smooth this out. This is one that's kind of been somewhat smooth, okay, rounded out, whereas this has all the corners because it's slowly being rounded or broken off the edges of it here to form those kind of round gravels or river cobbles, right? And so that's a type of erosion. This is through the abrasion itself. The last one is through solution, where you actually have chemical weathering causing the dissolution of the bed itself. So water is, natural rainwater is naturally acidic, and it will slowly dissolve some rocks. And when it does, it's basically breaking down those rocks and then taking those ions and taking them downstream. Okay, so here's an example of erosion. And there's some. If you can watch these, videos through the lecture slides if you want. Videos through this venue don't work very well because I get a lot of feedback back from it. But you can go through the links and the slides and actually watch these if you would like. They're fairly dramatic, both of them. But it's an example of this one here. Here's a house along its cut bank, which is not a good place to put a house. It's going to erode into slowly and actually erode that bank. So if you notice here, this house was before the storm, before the flood in a sense, was away from the stream a bit, but after a large storm, the hydraulic action, the abrasion, cut into the bank, causing it to move backwards over time, and now the house is being undercut by the actual stream itself, right? So that's a good example of stream erosion. Well, you have more erosion where you have more friction, okay? And so anytime you have what we call turbulent flow, where the water is going all over the place, you're going to have more friction. Whereas in places where it's going nice and smooth down, you're going to have not as much friction, and it's going to move faster. So here's a place where you have a laminar flow. It's moving nice and fast, not much turbulence at all. And then you have down here, you're going to have much more turbulence. In places where you have more turbulence, you have more erosion. Places where you have less turbulence, less erosion. Okay? So where in the basin would you expect to find each of the different kinds of flow to be more prevalent? Well, for us, it's going back to this stream area here. Up here, you have much more turbulent waters, much more erosion, more friction in these areas. As you go down, it slows down, and it's much more laminar. And so it transports the material, but doesn't really erode much. And then it slows down so much that it can't even move the sediment anymore and deposits it. So erosion, transport, deposition. Okay, so that's what we're going to be talking about: erosion, transport here, okay, and then deposition. Well, whenever a rock slows down, initially, well, not say the water slows down. The water can initially move a rock, right? So if it's going pretty fast, but if it all of a sudden slows down, there will be a point where that rock can no longer be moved because there's not enough power behind the water. And so if it can't be moved, it will be dropped. Okay, so whatever is the lowest velocity that a material will actually be moved, as soon as that velocity goes down, all of a sudden that sediment will drop to the bottom of the actual stream bed. Okay, so for example, in this case where we had the stream again, you have the faster water on the sides where you have more erosion, but then it slows down as it goes around the inside corner, so then and you erode this material and then deposit it here. Erode this material, erode it here and then deposit it downstream, right? So this is a type of deposition because of the different velocity changes that are occurring here. And this is what we call this diagram here, we call the Holstrom diagram, which means that as you change velocity, okay, different rocks will actually deposit. Okay, so if I had a really coarse gravel, some bigger deposit, okay, you'll have to have more energy or more velocity to move it. Okay, whereas fine grained stuff is not going to have much velocity to be able to transport it. Okay. But if you get to about here, you're now getting to materials that you can't move with that velocity anymore. You get it? So this is to kind of tell you where things will, if it's below this velocity, it will be deposited. If it's in this area, it will be transported. Prior to that, it will be eroded. It's a lot harder to initially pick something up than let it to have it keep going. And that's why there's a difference between the transportation and the erosion section. Okay, so there's three ways in which the rocks can be transported. One through solution. Remember, there's the solution erosion. Well, that means there's going to be also what we call a solution load, or we often call a dissolved load, where the actual rock is dissolved in the actual water and it flows downstream. Okay, that's why your oceans are salty, because over time all that dissolved load goes to the oceans and it's still dissolved in the water, and so it slowly, the total dissolved salts in the water becomes saltier and saltier and saltier until it's saline. Okay, then you have what we call a suspended load, where that stuff is small enough, I already have the diagram out here, that it can be transported but not slow enough for it to be deposited. So it would be transported in the water. So a great example of this would be the Mississippi River, where it's nice and brown. You're having a lot high suspended load as it goes downstream. Stuff at the bottom is what we call a bed load. So it's too big to actually be suspended in the water, but large enough where it can roll, slide, and maybe bounce along the bottom of the bed. So that's three different types of of transportation.